Hello, this is going to be a video series about the Plan 9 operating system. This is going to serve as the first installment in the series, which is just going to be a kind of short, brief overview of the entire system, some of its history, why I think it's useful to learn the system, and why I think you might find it useful to learn the system. First, though, to say a little bit about myself. My name is Moody. I work on Ninefront. That's a fork of Plan 9. We'll get more into that in a little bit later. And I have a list of some things that I've worked on for the system. Not comprehensive, but just to kind of give an idea of where my expertise lies, some stuff that I'm familiar with, and so you can kind of get an idea for things, my kind of familiarity with the system. So what is a Plan 9? Well, Plan 9 is a full operating system. That means it has a kernel, has a user space, and everything is all its own. We don't use GNU, we don't use Muscle, we don't use BSD. It's all original for Plan 9, which is quite unique. Usually, there's not a lot of systems that have we have our own compilers, our own kernel, our own libc. There's really not a lot of systems that do that. I mean, even macOS now ships something like Clang for their compilers for the most part. But I digress. Not super important. A lot of the design is in the same spirit as early Unix. Not necessarily Unix-like, I would say, with how Unix is interpreted these days, but a lot of the design and motivation was, a descendant of the original Unix philosophy of programs communicating in composable pieces. Plan 9 itself was written by Rob Pike and Ken Thompson and other members of the Unix room, Phil Winterbottom, Tom Duff, and so on. And what's interesting about Plan 9 is that it has this understanding that the world is now a networked series of machines. And any given person may have, a number of machines they want to access. And kind of the composition of resources from these machines is something that was very much at the forefront of the design of the system, which is really interesting. We'll kind of get more into the implications of that and how that works later. But just know for now that things are designed from the get-go to be network transparent, to be understandable and composable from a multi-machine layer of abstraction. So in order to really talk about Plan 9 and the reason why that it kind of is the way that it is, you really have to kind of understand some of the history of it. So I would say that Plan 9 was written with Unix in hindsight. Ken Thompson and Rob Pike, I think after working on Unix and using it for quite a while, there was some complaints that had kind of built up about the system. And they wanted to kind of use Plan 9 as a clean slate. Okay, let's walk it back. With this, we don't have to make any promises of compatibility. We don't have to do any of this extra work. Let's just try to get this right again. And the reason why this was kind of important and kind of why they couldn't do this in place with Unix has to do with kind of how the community at large around Unix had been going at the time. See, while Unix is also being used within Bell Labs, it also had kind of gotten out into the world. It was being used at places like Berkeley, U of T, that's the University of Toronto, and many, many other places. If you were a university with a comp sci program, you had a Unix license probably. And the thing is when students and professors get their hands on this type of software, they want to write code for it. And sometimes that code ends up kind of proliferating a lot. For other interesting historical reasons that is not kind of outside of the scope of this video, Bell Labs is not exactly interested in TCP/IP, so that was all done by Bill Joy over at Berkeley. Things like the VI editor, Bill Joy over at Berkeley, the CSH, which ended up kind of, Bash as a somewhat descendant of somewhat, that also started over at Berkeley. So a lot of what kind of moved the Unix world and now Linux world forward to some degrees were innovations and designs being driven by people not at Bell Labs. And this is kind of a stark contrast to how things work with Linux today, right? Like if Linus Torvalds wants something to change, he can, put his foot down and say, this is how these things should happen. I think this is the way forward. And a lot of people will listen and kind of, make that so. In the old days, there was no internet. Ken Thompson was not kind of, available to the world in a lot of ways for his ideas about how these things should work. Were largely known. So, people were kind of more free to just kind of, take their code and run with it. Just do things, fly by night, put code up, it gets adopted, and this is how we kind of end up with things that are to be a little charitable, things that are not exactly designed how I think Ken Thompson and Rob Pike would have designed them. Things like BSD sockets and IOCTL and things of that nature are a little on Unix in my opinion, but we're getting a little sidetracked here. In a lot of ways, I kind of want to point this out. I think Bill Joy and Rob Pike have a very interesting rivalry in terms of things that they did. They both wrote editors. They both they both had the graphical editors. They both were kind of like the chosen son of Unix in terms of innovating it, and they kind of have each taken the world in different directions. It's very interesting, I think, to kind of compare and contrast them. But again, don't want to get too much into it. And this, I'll say that this is mostly my own interpretation of this. There's no there's no stark evidence that this is exactly how things work. This is just how I've kind of interpreted the narrative. So to get back on track, what makes Plan 9 interesting? Well, I think the number one reason is the code is what I call human scale. One single person can understand all of the code in Plan 9. And that's crazy to think about. I mean, there are, in what goes on in a modern computer, the Linux kernel, the GCC, the tools that we use every day are reaching a point where it is impossible for one person to comprehend everything. I'm sitting recording this at a Linux machine, and I have no hopes understanding every piece of code that is required for my machine to boot. It's just impossible. The code, the line count, the complexity is all way astronomically higher than what is ideal. Not going to comment on whether or not it's mandatory, but it's certainly not ideal. So with Plan 9, the code is a lot less. We try to really be conservative with where we invest code, where we invest time, and how things move forward. So the kernel is much, much smaller. We have compilers which are much, much smaller. A lot of our utilities are much, much smaller. And this allows kind of one person to keep a lot of the system in their head, which I think really impacts how you're able to program the machine or program the system, and how you're able to understand and utilize the system when you don't have intentional blind spots in how you're using you don't have intentional blind spots when you're programming or reading the system or trying to configure it. It's all just kind of, you can keep it right up in your head. You can't. I'm pointing to my head. You can't see it right now, but just trust me on that one. In like I mentioned earlier, a lot of the ideas for how these things are constructed is based on Unix. A lot of file system interfaces, files are inherently network transparent due to 9p, and we'll get more into that in a little bit. We have first-class namespaces, which allows us to do a lot of stuff, both in the security domain, organizational domain. The namespaces are very powerful. They're so powerful that they have become a mainstay over in the Linux world. And of course, those namespaces have now been used to implement things like Docker. There's kind of a direct lineage between Plan 9's implementation of namespaces and how people use Docker these days. Kind of interesting historical tidbit. And all of this is done with a very limited system call interface. So the system creates this interface for here's how you interact with files, and we try to put as much on top of that file interface as we can get away with in order to keep that interface, that surface area between user space and the kernel to be a very, limited, very understood portion. So how does Plan 9 accomplish a lot of the things that it does? I mentioned the 9p protocol. That is essentially exposing a file system over a network. So you have some file system tree, you have your home directory, you'd like to make that available to someone else on the network, you use 9p for that. Something similar to NFS or SMB, but a lot simpler in a lot of regards. It's pretty easy to implement a 9p server. It's a lot more complicated to implement something like an SMB or an FS server. And I've implemented a couple 9p servers. Anyway, it's besides the point. Any program in user space can mount a tree over 9p. So bringing in a 9p directory or tree from another system is a namespace operation. So any process can mount something, which is a huge change from how things work over in the Unix world. And we can do this because we don't have set UID binaries. We just don't have them, don't want them. A lot of the capabilities of the kernel in terms of networking interfaces, pipes, the processes are exposed through files as well. So when you combine this together, and when you do so much with files, and some of it's done by user space, some of it's done by kernel, you kind of end up with this environment which is not necessarily a monolithic kernel, not necessarily a microkernel. People call it a hybrid approach, and I think that's pretty accurate, where the environment for which a program runs under is based on utilities both from user space and kernel space. But the key there is that the program doesn't necessarily care which interface is being exposed to it. If you have a pipe device, it doesn't matter, did that come from the user space or did that come from the kernel space? It doesn't matter. As long as they expose the same semantics, the program doesn't care. And that's really useful. And we'll get more, talk a little bit more about the implications of a design like this here. So to talk more about this, opening a TCP connection is done through /net/TCP. Everything is just done with open, read, write, and close. So that means that any programming language, on the system that can do these simple things, they can create TCP sockets, and that includes the shell in this case. You can do all of this open, read, write, and close with our shell RC, and you can create TCP connections without much work at all. Proxies can be achieved by having access to a remote /net/TCP. So bear with me here, I don't exactly have an illustration for this, but you have two machines, and machine A connects to machine B and has machine B export its /net over 9P. That means that programs on machine A can use that to transparently make use of machine B's network stack, which is really quite powerful. You can essentially get a proxy where I would like all my traffic to go through this remote machine. You can just mount that /net. Okay, everything I do is being proxied through this now. Easy. It just falls out of the design, as we like to say. SSH tunneling is a really good example of this, about the whole, is it being implemented by the kernel use space and that not mattering much? So SSH, you haven't used it before. SSH has the capabilities of proxying network traffic. So you can do, it's called SSH forwarding, reverse forwarding, sometimes called port forwarding or reverse port forwarding. So you'll connect to a remote machine and you say, okay, remote machine, make this connection for me. Or remote machine, listen on this port and forward connections over to me. Well, in Plan 9, we have this implemented as a program that connects to a machine through SSH and then exposes a /net from user space. So you can essentially use that /net, import it into your namespace. Then you can make connections that'll go through the SSH net, then will go through the real /net, and then will show up in the remote machine. And so you can have I can just start a web browser or whatever, and under this net TCP, and it'll just transparently use the remote system's network without any sort of knowledge whatsoever about what's happening. These things kind of, when you have these building blocks, you get a lot of really cool features basically for free from how these things are organized. And this is what I think is really powerful about the design used by Plan 9. You get a lot for free just by really paying attention to how you implement features. So, after I've basically explained why, I think Plan 9 is great, we should talk about, who is Plan 9 for? Who would make good use of the Plan 9 operating system? So I use it because I really enjoy programming in my own time. I like working on clean systems. Writing code for Plan 9 is a very enjoyable process. If you like programming in your free time and the notion of working on an operating system sounds interesting to you, I totally suggest to check Plan 9 out. There are, of course, it's not all programmers. We do, of course, have users that are less technical and more user focused, that don't necessarily write code for the system. And that's not me. I can't really speak to that experience, but there seems to be a desire there for kind of the clean and tidy interfaces. Kind of the way that Plan 9 works seems to kind of click well with these people that are using the system. I've often referred to Plan 9 as a sort of Zen garden. I work all day working on these complicated systems for my day job, and I come home and I get to rake gravel and deal with this kind of more idealized environment for Plan 9. So, of course, there's also times when you shouldn't use Plan 9. If you're expecting a modern web browser, don't use Plan 9. We don't have Chrome, we don't have Firefox, you're not going to be watching TikTok videos on Plan 9. We specifically, a lot of what Plan 9 is, let me back up. A lot of the benefits of Plan 9 are there because there was careful consideration for every new feature that was added. Adding complexity and features in order to reach parity for something like a web browser in the current age would essentially require you just kind of re-implement something like Linux or Unix on top of Plan 9 with all the features that would be required. So that's not exactly something we're interested in, nor is it something that we think other people should be kind of super interested in. There's some exceptions. We have NetSurf, doesn't really count, but it's there. If you're expecting some XYZ Linux or Unix program, if you want Emacs, you can't live without Emacs, you can't fathom using other programs, then Plan 9 might not be for you. The learning the system and utilizing it really makes sense. Where you walk into the system, you leave your assumptions at the door, and you kind of open your mind to experiencing the way how Plan 9 accomplishes the tasks that it wants to accomplish. And also, everything's written in C. If you hate C, you probably won't like programming Plan 9. That's just kind of a heads-up warning about that. It's not exactly written here, but I think it's important to say that, most people that use Plan 9, in my experience, don't use only Plan 9. Like right now, I'm recording this from a Linux machine that's connected to a Plan 9 machine. That's how I do most of my Plan 9 development. I know a lot of people that they do the other way, where they have a Plan 9 machine, but they will connect to a remote Linux machine and do things on there when they need to, or use VNC. So, you don't expect to, if you have just one laptop, you only have one machine, and you have to pick, Plan 9 or Linux or Windows or whatever, then just pick something that's going to help you get your job done. But if you have a spare machine and you want to kind of learn and engross yourself within a different sort of alien world of possibilities, then yeah, give it a go, give it a try. This is all just to say, walk in with a clean mind. Walk in with the expectation that you're going to learn something that you perhaps weren't expecting to learn, or use a program you weren't expecting to use. So that's a little bit, little speech about, kind of who Plan 9 is for, why you should use it. So the last thing kind of I want to talk about here is 9front, and this will kind of segue into the next part of this series, where we kind of really dig into how to set this up and how to use it. But for now, let's just talk about this. 9front is a fork of Plan 9 that's kind of continued the development. So Plan 9 is no longer being developed by AT&T. The people that worked on it are no longer at Bell Labs. 9front basically was people from the community saying we'd like to kind of have a repository where code bugs can be fixed, new features can be shared, and kind of built their own community around it, because there was some lack of community around the original releases. So it's a lot of work has been put into 9front to make Plan 9 work on modern hardware. UEFI, modern ACPI support, NVMe supports, like a lot of what people take for granted with that an operating system does for them was not exactly true of Plan 9, but 9front made it so. Lots and lots of bug fixes, small enhancements all over the place, new programs that I think are quite useful. So that's kind of, that's the current way I'd suggest using Plan 9 is to use 9front. It runs great in a virtual machine, so QEMU, Hyper-V, VMware, not VirtualBox. Don't expect VirtualBox to work great, because VirtualBox has some issues, but I digress. So the use of DrawTerm really makes it quite easy to use an iFront machine from a different operating system. So what I'm presenting this in is a program called Spit that was written by a member of the community. So I can kind of on full screen that here, and I have, that's my little editor here. This is what I was writing the presentation in, and all this is I'm recording this from a Linux machine, and this is what I'm using here is DrawTerm, and you essentially have a Plan 9 in a box type deal where everything runs as you would expect. You're actually remoted into the system. Its closest cousin, I would say, would be something like Windows RDP, where you kind of like connecting and you gotta get a desktop to a remote system. So, and I use DrawTerm a lot. I've worked on DrawTerm quite a bit. I think it's a great way of experiencing the system, and it's kind of low barrier to entry. So and like I said, we'll get more into it next time. But I really think that a virtual machine and DrawTerm on top of it is really how I suggest people kind of first dip their toes into the system. But that's pretty much all that we have for today. I hope this provided a good overview of the system. I hope that if you hadn't heard of this system before, this helps you understand a lot of what it is and why people might be interested in it. And I hope if this is the first time you've learned about it, you do feel interested enough to give it a check out and look to see if it's something that's interesting to you. So let me know in the comments if something was unclear, if you have any comments about how this was presented, any suggestions, things that you'd like me to cover in the future for other topics on Plan 9 or 9Front. Please let me know. And thanks. I will see you guys next time. See ya.